Thank you for the introduction, Rob. Now let's see.
Absolutely.
Okay. Well, thanks for the organizers for inviting me to speak here. And thanks for the catchy title you came up with. So quick, who am I? I've been working for Swiss Post for 13 years. My areas of interest include malware analysis and cyber threat intelligence, although I can only spend maybe 10 to 20% of my time on this. So this is not my full time, only working on this area. For those of you who haven't seen any of my previous talks, in 2013, I started presenting about PCAP malware and botnet for a couple of years. In 2016, I started talking about hunting with Sysmon data. And last year at BotConf, I presented my research about a threat group we named Desktop Group for the first time. Here's the agenda of this presentation. First, a quick introduction. Then I'll talk about how I try to automate malware analysis as much as possible and how I started using YARA to scan PCAPs, memory strings, Char files from Java rats. In the last part, I'll talk about Desktop Group, how we use YARA to block their attack mails, and YARA rules for some weird file formats. Setting expectations, I'm doing malware analysis mostly just on samples found in our email quarantine. Occasionally, I download samples from repositories, especially if they're related to my own. I'm not an expert in YARA rule writing. My skills are maybe advanced beginner level. I don't use disassemblers and debuggers for reversing. I use YARA for whatever works for us, which may not work for everybody else. Some examples are 5-6 years ago, but the later one are more recent as well. My goal for using YARA is the classification of malware families in my automated analysis. So what's normal usage of YARA? We already heard a few things in the previous talks. Typically, YARA rules should be precise, meaning clearly distinguish malicious patterns from benign ones. In my opinion, most YARA rules are for executables and carrier files containing exploits or macros, maybe some memory dumps. Of course, there's a lot more, but I'm just talking about the majority of them. And my rules will be a little bit different, most of them, and also a little bit simpler than a lot of other rules that you will be hearing about today. Quick shout out and many thanks to the admins and members of the YARA Exchange group, which I've been a member of since almost 8 years, and I've been able to benefit a lot of them, probably more than I was able to contribute. Now let's talk about how far you can go with automating malware analysis. I started using a commercial sandbox solution, Joe Sandbox, in 2013. And soon after that, I started scripting for automating the malware analysis process. In 2015 at BotConf, I gave a lightning talk where I first presented about the scripted automation for malware analysis. This is an overview of the malware analysis automation scripting process. The input provided are emails with attachments or files of any type that the sandbox can analyze. The script extracts mail attachments and uploads the files to the sandbox. When analysis is finished, all results are downloaded. Full analysis report in HTML, XML, and JSON format, the PCAP from network traffic, the dropped and downloaded files, strings from processes in memory and files, and the sandbox signatures. During post-processing, the script extracts files, registry keys, mutexes, and processes created, DNS and HTTP and TCP traffic from PCAP, and also runs YARA rules over files, PCAP, and memory strings, does hash lookups and file submits on VirusTotal. I also created a number of behavior rules, which then can be used to create SIM or Splunk searches or alerts and do hunting with. This could be abstracted to Sigma rules. At the end of the analysis, an email is sent out with the behavior and YARA rule matches at the top, often giving a good indication of what malware family this sample belongs to. Here we can see dark comet detections from memory strings, mutex, and PCAP. Just a few words about the behavior rules. There are 7 categories for file system, network, persistence, process, registry, sandbox signatures, and malware-specific YARA rules. Here you can see a number of behavior rules from rats. Dark comet is identified by the DC logs directory created, the default prefix of the mutex, and a registry key that marks its execution. The majority of these behavior rules are just greps for specific strings in files created from post-processing, like files created, mutex created, or registry key created or modified. Here are just a few more slides from the lightning talk for reference later. I will not discuss all the details. Here, behavior rules for persistence methods, for network behavior, especially looking for TCP connections on non-standard ports, which usually or often is CNC from rats. And some file system IOCs looking for file names, directory names, and memory strings, mutexes in memory, process childs, parent-child relationships, and command lines. Over the 7 years, I analyzed between 50 to 400 samples per month and about 2,000 to 3,500 per year. By the end of 2015, it was just around 5,000 samples. Today, there are about 17,000 samples analyzed. To some of you, these may be small numbers, but to us, the value is high since these samples were found in an intrusion attempt, which was blocked here at Swiss Post. Now let's look at using YARA rules for some maybe uncommon file types, starting with PCAP files. Early on, I started looking at PCAPs using Wireshark and searching for patterns for identified malware families. Here are some PCAPs from 3 different NetWire rat samples. I found that there were only a few magic byte headers in this binary protocol and wrote this simple rule. This was likely one of my first rules since November 2014 was the oldest date I found in my rules. This is a PCAP from Dark Comet sample and a rule detecting the beacon, hex string, or bytes. Another very simple rule, but whatever works is good enough. This is C2 traffic from Luminosity Link Rat, where I found this packet string used as delimiter. The rule looks for more than 3 delimiters. Here's an overview of the YARA rules for PCAPs with the number of samples matching in front. To the left are rules for ransomware families, mostly Locky, and on the right, a number of password stealers and keyloggers, and some rat families. And we've already heard ransomware still being around from the previous talks. So in 2016 and 17, I was tracking the different Locky variants from malspam runs. I was looking for the different URI paths being used to download the DLL payloads. After September 2016, the DLL downloads were mostly using XOR keys. So I kept track of 34 different XOR keys that were used over the span of about 1 year. In the table, you can also see the number of days and number of samples for each variant. Most of the PCAP rules were developed from 2014 to 2017. Starting around middle of 2017, I integrated Suricata in the scripts to scan PCAPs with our production IDS rule set, which also proved to be very useful. So now let's look at YARA rules for memory strings and mutexes. These rules look almost too easy because in memory, you'll easily find all the juicy strings identifying certain malware families, like these password stealers and keyloggers. You can see limitless logger, Hawkeye keylogger, predator pane, night logger with easy strings to find in memory. Here, another rule for iSpy keylogger and a generic one for the legitimate Nearsoft tools, which were integrated in many of the mentioned password stealer families. Here, a couple more rules for some rat families. On the left, some strings typical for nanocore rat, matching at least 4 of them. And on the right, I enumerated 113 commands from Remcos rat with needing at least 70 matches and 2 fairly unique strings at the bottom. This is an example for a mutex rule, searching for one of the 3 different mutex prefixes seen in many dark comet rat samples. The rule matches on mutex created and on memory strings of the app launch exit process, which also was matched by other YARA rules as dark comet. Next, let's look at YARA rules for char files from Java rats. Here are some bash commands, how I searched through my char files from 2015 to 2016. For each char file, which is basically just a zip file, I list the name, the MD5 hash, scan it with the Java rats rules, and display the files inside the char or zip file. You can see the output on the bottom. Sometime in 2015, I started tracking the different adwin families by the file names inside the char files. This is an alien spy variant identified by the a.text, b.text, and main.class. Each char file also must have the manifest.mf file in the meta.inf folder. This is a JSocket variant identified by the server DLL and password.txt files. And another JSocket variant I've identified by the stubcito and textito files. And yet another JSocket variant identified by config.perl and start class files. This is an overview of the YARA rules for Java rats with the number of matching samples to the left and the first seen sample to the right. Each sample analysis uses a folder with the analysis date in the folder name. So these samples were analyzed from early 2015 through February of 2016. The next part is about desktop group and using YARA for email headers and body, not attachments. As a quick intro to desktop group, here are a few slides from last year's presentation. 2.5 years ago, we started seeing malware mails to the to the same few targets and try to identify some patterns and links between them. Soon I started an Excel spreadsheet to keep track of all the data points used for correlation. These include a number of email headers, along with malware hashes, family, and C2 details. The list has grown to over 140 attack mails analyzed to date. Where does the name desktop group come from? I started noticing desktop names in the message ID headers, which are pseudo-unique random generated for each Windows desktop installation. This was one of the first emails from February 2018. This is a later mail from April 2019 with a different desktop name, which also appears in the received headers along with an IP address, which is likely where the attack mail originates from. In another mail, there is a Windows server name in the received headers, but just a regular server host name in the message ID header. So I started keeping track of the different desktop and server names used in these mails and how long they were reused and seen in how many mails. One desktop name was seen in 12 mails over almost 260 days. There were also some other strings or names reused in different headers as well. This is a YARA rule from late September last year, which can block any mails containing any known desktop names. The rule could be made more precise when matching the full message ID header instead of just a string anywhere in the mail. But for us, this is good enough. This YARA rule matches any known string or IP address seen in received headers, but again, it would match them anywhere in the email. And this rule matches known from addresses or email addresses from X sender or authenticated sender headers. About 3 months ago, I found them using links in mails to this FinoDev group domain, where some of the mail bodies were base 64 encoded. So I wanted to match that domain plain and base 64 encoded, where I manually created the 3 permutations. We've seen Quasar, Adwin, and Wishrat samples hosted on that domain. Since then, about a month later, Florian tweeted about the latest YARA version, which introduced the base 64 modifiers. So this just got a whole lot easier to do now. And Sans ISC also had a few diaries about this new feature with examples and a video, and there is the official documentation, of course, as a reference. So just about a month after putting in these YARA rules for mails, several mails without attachments got blocked only due to these rules. So this was already a success for us. In February and April this year, another 2 mail runs were blocked. And in May and June, some bounces were detected where the original mails were blocked due to attachments. Of course, these rules need to regularly be updated to stay useful. Now let's look at some weird file formats used by desktop group. First, the MSI plus char files. Security in Bits put out this tweet a couple of weeks ago, about an interesting techniques seen for RAT sample. At the same time, I was also just looking into this and replied to his tweet, providing a number of sample hashes I found through my YARA rule development. And I also put in a warning that I will be presenting about this. He also linked the virus total blog post in his tweet that describes this technique quite well. And that was from last year already. And just a couple days ago, he published a blog post describing this in even more detail and with analyzing a sample and providing a YARA rule, which is TLP white. So the most important takeaway from this is that MSI files are read top to bottom, and char files like zip are read bottom to top. So a malicious char file can just be appended to a benign and signed MSI file and will execute with the extension changed to char. Here's the YARA rule that I came up with, looking for the MSI header at the beginning, matching at least 3 of the 6 typical strings in MSI files, and having a manifest and class file as needed in a char. Here's the YARA rule from Security in Bits, and very similar, but still different. Instead of strings from MSI, he's looking for some magic bytes from a zip file, and he has a file size limit, which he lowered because there are smaller samples matching this as well. So these are 2 rules for the ReadyRat Java malware. The rule to the left matches a char header at the beginning. The rule to the right does not. So the rule with no char in the name would also match if the char was appended to an MSI file. Here are some samples that matched both rules, MSI containing char and ReadyRat no char, because it's the zip file is appended to the MSI. Some other samples were also MSI containing char and were later identified as Adwind. One of the earlier samples analyzed was a Java malware that I was not familiar with yet. So I tweeted out a malware challenge, giving the C2 domain and a link to the sample. I saw the char would download a legitimate Node.js installation and create a persistence to run node.exe. I didn't really find the malicious component in here. So about 2 weeks later, Trend Micro published this blog about QNode service, which was the name given to this still quite fairly new Java malware. And I put out a tweet thanking them for coming up with this name, QNode service. Now let's get to the last part, RTF files and Excel. This is an analysis from an RTF file that I discovered about 3 weeks ago. I've seen similar samples much earlier, but I never really dug deep. In the overview of screenshots from the analysis, we can see several dark blue windows pop up and the menu bar changing from Word blue to Excel green somewhere in the middle. Taking a closer look, we can see Word spawning a PowerShell command window on the right, and Word changing the menu to Excel green and displaying a spreadsheet window on the page. So let's look at the process tree and command lines. The RTF sample is opened with WinWord.exe, and several Excel, WScript, and PowerShell processes are spawned afterwards. In total, there are 7 Excel processes and 7 PowerShell invocations with the same command line. One PowerShell process has a unique command line different from the other 7. You've seen less than half of the full process tree and command lines before, but it's very repetitive. So let's take a look at the first PowerShell command line, which occurred 7 times. It's downloading and executing a VBS script from a URL on the IP address. The first line is also an obfuscation that resolves to new object, which is likely a common string for detecting malicious PowerShell scripts. The downloaded VBS script is again heavily obfuscated and uses PowerShell again. The PowerShell command line started from the VBS decodes to this. The test connection will loop forever unless an internet connection exists and a ping to google.com returns a reply. If there is an internet connection, a JPEG file is downloaded from the same server and directory as the VBS script. The JPEG file was not online anymore, but I found it on VirusTotal and could download it to analyze. This file was over 3 megabytes large and contained hex code with a dash as delimiter. So maybe you already guessed or suspected it. It's not really a JPEG file. Using CyberChef, it was again easy to decode that hex to PowerShell code. In the decoded PowerShell script, there was a huge blob of hex again. And after deobfuscating one line, it appears that gzip was used to compress it. So I was able to get a PE file from that huge hex blob. But it was also easier to just analyze the PowerShell script in the sandbox. The analysis result was quite good. We can see that PowerShell spawned the legitimate Notepad exe, and a YARA rule detected NetWire rat in the Notepad process. We can also see that PowerShell injects a PE file into Notepad, and that Notepad connects to port 3606 on that 81 IP address. That IP was resolved from that Microsoft something.dns domain. So this was quite a complex and extensive infection chain for this rat, starting with an RTF containing some Excel with macro. Here's the YARA rule for these RTF files containing Excel OLE streams inside them. This is still very much experimental and under development. So if someone is interested in helping and collaborating with this research, I'll be happy, and just reach out to me after the talk. Just to throw in one more type of YARA rule, I was also looking at last saved by and author from Office files with malicious macros to hunt for files possibly or hopefully created by the same user or actor. These are some bash commands, how I use YARA to hunt in my own samples. We see 72 samples matching the RTF plus XLS rule on the very bottom, and 2 username matching 3 or 4 samples. From the RTF plus XLS samples, I search for hashes with multiple samples, 2 or 3. And looking at the file names from these hashes, I can spot duplicate submissions with the same or similar file names and different file names for the same hash, which could be additional IOCs for mail attachments to hunt for. I also tried my YARA rules for retro hunting on VirusTotal and found 89 and 178 samples for these 2 rules over the last 3 months. And I do have the hashes. If anyone is interested, I'll be happy to share the hashes. And I also tried retro hunting on the ReversingLabs A1000, and I found 200 samples for the MSI plus Char rule, MSI containing Char, and 250 samples for the RTF containing Excel rule. I was just kind of playing around with this since I'm not using this regularly. And I'm sure some of the other speakers and listeners are much more familiar with YARA hunting on these platforms. I just wanted to have tried it at least once. So I think we're still on time. And this was basically my last slide. Just a quick recap. I think we covered all the topics from the outline. And so I'm not sure how much time we have for questions. Here's my Twitter handle and my blog, where you can find the public presentations. And with that, we can see if we have time for some questions.
Yes, thanks, Tom. We have one question. So the interesting file format that you are applying YARA to, PCAP, packet capture, are there any tools that you would recommend to help apply YARA to packet capture, or do you just apply the YARA rules directly to a PCAP file?
Okay, yeah, good questions. I started using YARA to match patterns in PCAPs early on, and then eventually I started using Suricata, or I guess you could use Snort or any other IDS to scan the PCAPs with some IDS rule sets. So that's kind of what we started doing in mid 2017 for the past few years. So YARA for PCAPs was only like an early on thing that I did. And basically to reiterate, my YARA rules are mostly just run over the analysis result from Sandbox. So I don't need to be as distinct between benign files. I just need to distinguish different malware families from the analysis results of the Sandbox, which include PCAPs. Does that answer the question?
Yeah. Thank you, Tom. Thank you very much.
Thank you.
And
thanks for having me.